Is everything working? Okay, we are live. So hello, welcome. Last time we finished, or rather, ended our stream with a bit of a teaser. We made it possible to spawn a cube, and obviously it's not working for some reason. Oh right, because we commented it out. Yeah, we made the spawning the cubes, or rather rendering them, in a bit more efficient way. And we also created this voxel type, which would give us the ability to have more than one type of block, so we could distinguish them. And we also made a simple function that would show us the limitation of our current implementation, which is the time it takes to render all of it. And I said that we'll be working on making it a bit faster. But that's not a fun job. Optimizing things is usually not a fun job. Today is a fun day, so let's make all the types. So I've made some textures. Let me import them to the project. While I'm importing them, I deleted them, I think. Give me a second. I can tell you that I made the whole project, I uploaded it to GitHub, so you can check it out. The link will be somewhere there. I don't know where it will be, but I will add it, but it will be there. And I was dumb and I didn't record the last stream, but this stream will be uploaded to YouTube. So yeah, okay, I imported the 3 textures. These are really basic textures. I think they are 64 by 64 pixels. I said that we would use, for example, the hulls, the hull type for some kind of spaceship building or something like that game. And I made a simple texture, just one texture, and change the color. That's it. So now we can work on actually applying the texture. As I said in the previous stream, we will be using something called UVs. UVs are basically the what tells the, let's say, the things that renders objects on screen what texture should be applied, or rather which vertex is where on the texture. To do this, we should, or rather for now, will use one big texture instead of couple small ones. Okay. And we'll be using a sprite atlas, I think, for it. It will be the best idea, but I don't seem to get it working. It should be working. I haven't done this ever, so quick Google. Sorry, I thought this should be working, but well. Quick Reddit search? No. Okay, I will just do it manually. I will fix that later. So I'll fire GIMP. If you don't know GIMP, it's a really basic but really great editor for images. It's not vector based. Yeah, it's raster based, I think. That's the name. I will just put the three textures beside each other. Oh, they are even smaller. How big are they? So as you can see, there is some Windows. Tool options, not tool options. Sorry for the mess. There is. What's going on? Where is my window? Where are my windows? Toolbox, not toolbox. Okay, let's do it even simpler. I should be able to do this here. Or even not. How to make it? Fuck. Sorry for the mess. Oh, yeah, it's here. I found it. So, we don't need this. Okay, so let's make a new image with the size 3 times of our original image, because it's 3 times. We have 3 textures, and let's just put them into the. How big is it? It's 17 by 17 for some reason. So let's place them, yeah, as a floating object. Let's select it. Enlarge it, or rather image, scale image, to have it 17 times 3 by 17, yeah. We can delete those because we don't need those. And now we can paste it. Let's move it here. Let's get the iron wool and the cobalt wool. Not this. No, one steel wool. Oh my god. Okay, I get it. I want to place, yeah. Now, iron wool as a floating object. select whatever, and now cobalt hull as a floating object. So we have this texture. Let's export it. You will see now my mess. Desktop. Let's call it textures.png. Yeah, export it. We can close it now. Discard changes. Okay, let's import this texture to Unity and leave it as a texture. Don't use it as a sprite. We want it as texture. So we have the texture. Now we want to apply it. As I said, UVs range from 0 to 1. So if we, for example, wanted to have a block, whatever block, to be a steel hull, as we can see in this image, you would have to get it from 0 to 0.33. I'll just change it to point, so it will be like real pixel, not this blurry mess. And no alpha, because we don't want any alpha. Okay, so let's code it. In the mesh creator, in the create phase, we also want to get the type of the cube we are mapping. So voxel type, and we'll also need some kind of indication where this texture lies on this. And how can we do that? With a simple array for now. That really doesn't matter what we'll do. We just need something to indicate it. So let's make another function like that. Okay, maybe after private. We want a vector to type to texture to UV start, and we get the voxel type. Why do I say UV start? Because we'll always mark the bottom left corner. We'll only get the bottom left corner, and we know what's the size, how many there are, so we don't have, so we can calculate the rest of the corners. So let's make a private const int, or vector to int, which will be the dimensions of the texture. So for now it will be 3 by 1. Texture dimensions equals new. Oh, because it can't be declared. Okay, so texture dimension x, which will be 3. We cannot use vector to int because it's not compilation static, which basically means it's not the same. Like the compiler cannot determine if it's the same every time you compile it, because it has to be the same when you compile it, not when you run it. We have to also pass the type here, which is like voxel dot value, basically. Okay, and now we can get to the type. So switch on the type. So empty, we don't care, because there'll be nothing here. We can just return vector2.0. We really don't care. For default, we'll also throw an error, an invalid voxel type. And if we take a look at the texture, we can see that this is the steel, this is iron, and this is cobalt. So this will be the 2/3 and 0. So iron help return vector2, new vector2. That will be 2/3 and 0. Steel is 0, 0, and cobalt is 1/3 and 0. And that's it. Oh, it has to be static, obviously. Static. Now, later we will do a automatic creation of the texture, automatic calculation. We won't have to add every texture here. You don't have to worry about it. So now we have the UVs, we have to add them. So let's create the UVs. var UVs equal new list of vector2, and they are assigned per vertex, so we can do it in the create phase. So let's pass them. Ref list of vector2. It's vector2 because it's the position on the texture. Mesh UVs. By the way, I'll show it later. Ref UVs, or I can even tell now whatever. These are usually treated as the values, right? So normals will be used as normals, how the light is positioned or whatever, how it is reflected or whatever. But you could pass anything that matches the types to these parameters, and then use your own shader to use those parameters. So this could be, I don't know, the positions of some weird objects in the scene or whatever. It only depends on your shader. The default shader uses them like what we are using, and add them so we won't forget later. As you can see, there's a lot of UVs you can pass because there's a lot of textures you can pass, but for now we don't care about it. So UVs to array. Now let's add the UVs. So mesh UVs dot add range, and this will depend on the type we're using, and we obviously made a function for that. What's the problem? The problem is that I forgot about UVs and how easy it would be if I would do this properly, and all of this is clockwise. That's good. Problem? They are not starting from the bottom left. So we will have to change all of these to start from the bottom left. Why? Or do we? Maybe we don't. Let's try it. Maybe we don't. So let's calculate the base UV. So var base UV equals type to UV start, UV base, and this will be the type. And just add base UV, base add range, it has to be a range. So new base UV. We also have to do this clockwise. So bottom left, then bottom or top left. So it will be plus y. So plus vector 2 dot up divided by the texture dimension y. Then plus 1 because we want to offset it. Oh no, plus up and plus right by x, and then only by x, and this can work. I don't guarantee it should work, it will work, because I don't know if the position of this or where they start matters, but it should, or it will maybe work. Let's call it that. Calculate the base UV, bottom left corner. Add the UVs. Okay. By the way, is someone there in the chat? If so, can you write something? Okay. Let's test our script. But first, obviously, we have to add the texture. Let's see. Oh, I didn't add any blocks. Right. You didn't see, no one said anything, so probably no one is watching, but whatever. So set block, set voxel block, no, set voxel. Let's make it 0. Voxel type is voxel type dot iron hole, and update true because we want to update it. So let's start the game. And yay, it's rendered properly. We have all the correct textures. Nice. Let's test the other ones, so we know that we didn't mess up anything. So this will be vector on the right, and this will be cobalt, and this will be left. It will be steel, and it should still work, I hope. Yay! Wait, right is there. Right, yeah, it works. Nice. There is one problem that I will fix in the meantime. I don't want to bore you with it, and the updated version will be pushed to GitHub. That I talked about it. It works, but the problem is, if we would have a texture that is not rotatable, so for example, I don't know, a arrow or something like that would point in given direction, and we want to point to a given direction, we would have to make it better, because right now the textures are rotated randomly, like maybe not randomly, but that rotated in different ways on every face. We can see that if we would open the texture in GIMP. So show an explorer, edit with, or even with Paint 3D, whatever. Let Microsoft be happy. So let's zoom in, and for example, we'll add a blob, like right here, and you will see that it's not positioned in the same way. No thanks. In the same way on every on every face, or at least it shouldn't, unless we are really lucky. Oh yeah, you see this? There it's the same as there, but there is different. We cannot control the up because up will have to be faced some way, but up and down are not the same either. You probably think how to make a block that has different textures in one block. For example, we want the top to be red and the bottom to be white. It's also doable. You just have to instead of always assigning the same texture, we would assign a different texture depending on the face. We will also do that even today if we have enough time. But right now, I promised another thing: placing blocks. And let's do this. We want to, for example, first thing, we want to change how the camera is positioned because it would be useful. And then we can click on the block with a left click to add some block, some chosen block, and left click or right click to remove it, for example. I don't really care how it's mapped. It's in your game how it will be done. We won't do anything like inventory or anything like that. Just one will choose iron, two will choose steel, and three will choose cobalt. That's it. So let's make another script called camera controller, because we want some control over camera. It'll be really simple. Let's get rid of this. Public mono behavior, and on update we'll just move if transform the position plus equals new vector 3. X will be input dot get axis horizontal, input dot get axis vertical. Oh no, it should be Z, and this will be times transform dot rotation, and that's it. That should work. Oh, and the times time dot delta time, and maybe add a speed variable. So private float speed, and we will do speed plus equals input dot get axis mouse scroll, I think it is. Let's check it fast. Project settings, input axis mouse scroll wheel. So mouse scroll wheel times time dot delta time times 4, just an arbitrary number. Okay, So we want the speed, and also we want a rotation. So transform dot rotation. Do we want to do this like that? No. Transform dot rotate, and the vector will be new vector 3. We want the x and the y, so input dot get mouse, no, get axis mouse y. I think it should be inverted from experience. Input dot get axis mouse x and 0. Oh, it's automatically 0. Okay, and this should work, I think. So let's attach our script to the camera. Okay, we can rotate around. Oh, it's a bit funky. Main camera. Why is it? Oh, because rotation not. Okay, I know what's going on. We just need to do this. Transform dot Euler angles plus equals this times this time. I think that should be it. Okay. It's working, but it's super slow, so let's make it like 10 times faster. I don't want to write a really good script, I don't really care. It's too slow. 50 times faster. Why did it crash? Can someone tell me? Or know that the Unity crashed because I know the behavior. Like sometimes when you when you are too fast, let's say, so it's compiling the project, and you hit play. It usually waits to compile and then starts the project, but sometimes it doesn't. It just runs the project, or rather tries to run the project. Yeah, it's okay. Can we move? No, we can't move. Or we can move, but really, really slow. What's the speed? Debug. The speed is really low. First, let's make this times 20. And the base speed maybe 1 and not 0. Okay, that will be better. And I think the scroll wheel is inverted. No, it's not inverted, it's okay. Okay, now we can move. Oh, there is no up and down. Okay, now we can have the basic movement. We can also confine the mouse. So I think it's called cursor dot lock state equals confined. Yeah, that means it will be able to move, but it will not be able to escape the window. So you can see. Oh, it shouldn't. Well, never mind. Okay, I had the basic movement. I don't care for a better one. So we have the movement. Now we need a ability to click on the block and place it, or click with a different mouse button and remove it. So how can we do this? We can do a raycast. So that means use physics, and then depending on the point that we hit, we can remove a block that is adjacent to it. But you probably guessed there's a problem with that approach. We won't be able to use physics because we don't have any collider. Like we have only a visible mesh, but not a interactable mesh. We can fix that real quick. Let's just add the collider. So in the voxel map, in the update mesh, we can just do game object component mesh collider shared mesh equals mesh. That's it. That's the same type of mesh. So we don't have to do any funky things to make it work. Let's just add a mesh collider. And that's it. It should work now. As you can see, it should... Does it have a collider? Oh, we have to mark it as convex. That I forgot about it. No, we cannot mark it as convex. But why? Convex means it's well, it's convex. Like I shouldn't have to explain this. We can test if it works by adding another block up, because convex will remake the mesh and non-convex won't remake the mesh. Oh yeah, you see the convex one remakes the mesh. But it should work. I think it's just not visible. Yeah, it should work. We can test it easily, I think. Just add a cube up, make it a bit. Add a rigid body, not to the normal rigid body. Yeah, it collides. It works. There is no problem. We just don't see the collider. So we can now make a raycast. So let's make another script attached to camera called Voxel placer. Let's add all the usual things. Okay. And what we need to do? We need a function that will place the block and will remove the block. So public void place and the selected voxel type, and a public void remove. And we don't need a type because we'll just remove what it sees. So in the place we have to get the block we see and the face we see, because it will basically work with that. We get the block that we see and then the face we see. We use our face direction, we can make it public, and from this face we'll extract the direction voxel face. Okay, we have to make it public too. We will extract, we'll get the direction we should go, and then place a block here. So we need other function that will get the current block under the cursor. So public vector3int, because we can get the block by a position, we just care about the position. Public vector3int get block, get voxel under cursor, and it won't take anything, but it will, or rather it will take a variable out voxel face no, we want to use like mesh creator not voxel face, yeah, face. And what does it mean, the out? It's the same thing that we use in the try get value. We'll just return another value, which is not normally possible through this. Okay, so first let's get the array from the how do I say it? Let's get a ray that will be from our camera to the thing that we point at the mouse. So let's get the camera. I will just do it in the start because it will be done many times, so it's better to just use the get the camera once. So private camera, and that's not how we name it. Camera equals camera. No. Get component camera. I know we have a camera. No, there is not. There should be a game object camera. Oh, they removed it. Never mind. So I have the camera now. Camera. Screen point to ray, and we need the screen point, so the mouse position. So input dot mouse position, and that's our array. So var array equals this. Now we need to cast it. So if physics dot ray cast ray. If not, we set the face to -1, so a invalid value. We can just cast a mesh creator dot voxel. We can cast a number to it, or we should be parentheses. Funny. Okay, we can cast a number to a enumerable because enum is just a fancy number that the user can see better. They start from 0. If you take a look, like north is 0, south is 1, etc. But we cast a -1, so it's an invalid value. And we'll just check if the voxel face is -1. And we return vector3int 0. Okay. We don't want to specify max distance, but I think we have to, so let's just say a big one like 1000, and don't care about anything else. Okay. Oh wait, we care about the outcome. So out var hit. It's the same thing as here, so it will return a new value called hit. So the hit is a raycast hit type, and it has a something called point and also normal. The normal is the thing that we care about, because it's basically the normal that we set somewhere there, here, and the normal is the same as the direction. So we could get, I just realized you don't need to have a face, you can just have vector3 direction. So we can just set the direction equal to hit dot normal. I will do some out vector in position, and I will try get voxel, and it will be a bool. So return false. So we'll just say that we try to get it because we don't know if we will get it. So position will be just vector dot 0, and direction will be just equal vector 2 dot 0, because we don't care what it is. Now direction is set. The position will be basically I know how to do it. No, I don't know how to do it. The position will be the hit point, the point we hit, plus the half of the opposite direction, because we know that from the center of the block to the border point, let's say, there is half a meter or whatever Unity uses. So, and we know that direction will point from the block to some space, and we want point from the space to block, from the point to block. So we can just set the position to new vector3 int. No, wait, not new. Vector3 int, because we want to cast it to a vector3 int. Hit dot point plus hit dot normal by 2. I think it should work. Can I cast it like that? Oh, I cannot cast it like that. I have to do it manually. Okay. So let's say var raw position equals hit dot point plus hit dot normal divided by 2. I will write it as times 0.5 because division is slower than multiplication. And we just have to round it. So position equals new vector3 int math f dot round to int raw position x, and let's do this 2 more times. Dot y dot z and return true, and that should work, I think. We can check it. let's just leave the place and remove. We can check it if it works by doing if info.get mouse button down 0 debug.log. Oh wait. Try debug.log. Try get value under cursor. Out var position. Out var direction. Out. Okay. And debug.log position and debug direction. And now let's attach the script to the camera. It's voxel placer. Save the scene and try. So we can click on this and it gave us a wrong position. No, it's a direction. Oh, the position's also wrong. They are both -1. Obviously, if you click on, oh, we don't see it, sorry. Let's dock it here. Let's make it not collapsible. Okay. If we click on this, it will give us the position of -1, 1, -1. That's bad. But the direction is okay. This is also... Wait, if I click on the lower side, and what if I click on the... Okay, so the problem is... How to solve it? The problem is with the X, and the X is which direction? X is this. If we come closer, this gives us 0, 0, -1. This gives us 0, 0, -1. Oh no, that's Z. That's Z. So if we come to the other side, it's +1. No, it's 1. It's 0.01. Why is that? Did I added the direction? Not. Okay, that should solve the problem. I think that should solve the problem. Now if we check, yay, it calculates properly wherever we click. That's good. Oh no, it doesn't. It doesn't. So it calculates properly here. It's 0, 0, 0. It's the second value. But up here, it's 0, 1, 0. Because where is the center? Let's check where is the center. 0, 0, 0. Why is it offset? That may be the reason. It's offset for some reason. Now it should work. So if we click on the top, it's 0, 0, 0. If we click on the bottom, it's 0, 0, 0. If we click there, it's -1, 0, 0. Everything works perfectly. And if we click on other face, it will still work, but it will give us a different direction. Yay! Okay, everything works. So we have this done. Now we have the place and remove. Place will be really simple. We just get this. So first let's copy this. So if we didn't hit anything, just return. And then we want a voxel map, so we want a voxel map, reference to voxel map, so private voxel map map. I will do a bad thing. Oh no, I won't do a bad thing. I will make it serializable. That means we can save it from editor and just make it a map dot set voxel position to our type. So type. And remove will be also really simple. I can do a place here. For right now, I will do just iron hull. And remove will be also really simple. So let's copy it, and the type just will be voxel type dot empty. That should work, I think. No, because we are really dumb. We just want the position to be offset by the direction, but also we want the direction to be a vector3 int, not a vector3. So we need to cast it. So int hit dot normal dot x, and let's do this 2 more times. It's a shame that there is no like automated way just to cast it easily. Like it would be so much easier to do this. And now position plus direction. Now it should be, because we would place in the same block and we want to place on a adjacent block. We have an error. We didn't set the map. That's right. So we just need to set the map. And now we should be able to make it work, whatever it is. Yeah, it is. Yay! We can place our objects. There is a weird seam on this, but no, there is nothing. Oh, it's just a wrapping. Okay. The textures are wrapping a bit, but we don't care. It's a not problem for. So we can place the objects. We should be able to remove it. No, because we didn't add this. So let's add removing it. It will be just mouse button 1 and remove. And that's it. We have block placement and placing and removing the blocks. It's setting it to steel hull for some reason. I mean, I think it's setting to empty, but it's rendering it as a steel hull. Let's check why. Oh, I know why. Because we try to render everything that we have in the voxels, and we should render only things that are not So we can just do where. It's a linku, just like we used somewhere there. I don't remember where x near is not voxel, no, x dot value is not voxel type dot empty, and that will fix the problem that air was rendering. Yay, now we can remove the blocks, place the blocks. There is no problem. Nice. So we have the basic block placement and removal. But I want to show you a problem for the next time. Obviously, if you are in the block, there could be some problems with that, but you shouldn't be, because you would probably make some kind of collision system that would prevent the camera from entering the blocks. Okay, I will make a contraption, but we don't care about it. We care about something else. I will just simulate it because it would be too much placing, too much block placement. So if I make a quick calculation, it's 215, I think. No, it's 16. Okay, 16. So divided by 4 divided by 6. So we could have, okay, so give me a moment, someone is ringing the door, so I'll be back in a second. Okay, I'm back. So I want to simulate a situation that could happen if you would play with our blocks right now. Let's say we want to build a big contraption, for example 12 by 12, 13 by 13 by 13, but we place every other block. So that would mean that we have a 4, let's place a 4, that will be x, length will be 26, but we plus equals 2. Let's make a y and a z. And let's place a block. So set voxel x, y, z. Wait, it's not what I want. Right? Yeah, it is what I want. It is what I want. So the position will be this. X, Y, Z. And let's just make it a voxel type still, and don't update because we don't want a lag. And we want to update now. Right. So if we play this, it will work just fine. It's a big contraption. After a quick calculation, 13 by 13 by 13 is about 2200 blocks. Let's make it a bit bigger. Let's say at 30 and 30 here. So it'll be 15 by 15 by 15. It's working perfectly. Our system is perfect. Oh wait, it shouldn't be perfect. Oh, it's not perfect, as you can see. What's going on here? This doesn't have some faces. What's going on? Unity has some limitations. We can count it. 4, 6, 8, 10, 12, 14. So it failed while rendering the 15th wall. Rendering. The blocks are still here. If we would check our dictionary, they are here. What's the problem? The problem is that Unity can only handle 2 to the power of 64, 2 to the power of 16 vertices in one mesh. What does it mean? It means that if you would try to make a really big world with only one mesh, it would fail because there will be too much vertices. After a quick calculation, we can see that every block has doesn't have neighbors. So it has 6 faces. Every face is 4 vertices. So every block is 24. 24 vertices. After dividing 2 to the power of 16 by 24, we get roughly a 2800, I think. I can check it real quick. It should be about 2400. Oh, 2700 with something after the comma. So let's just assume we can only place 2700 blocks in our we can only place 2700 blocks, because if you place more, there could be a problem. Doesn't mean it has to be a problem, because it looks better. Because if we would place just one big block without spaces, there would be a lot less faces. So we wouldn't have to worry about it. But we always have to count for the worst possibility, not the best one. So how can we solve the problem? We can just split the mesh into chunks. Yeah, it's a name that I use from Minecraft. I don't care. And to be how to call it? To be oh fuck, I forgot. To be safe, we only can use 2700 blocks in one chunk. So we'll make a chunk, a square of up to 13.92 blocks. I don't know how to make a 0.93 blocks, so let's make it 13. I know it's not a nice number. I know it's not a square of 2, but I want to have a confidence that it won't crash ever. And even if we make some mistake, there will be more vertices, there will be less vertices. I don't know, we could add a special block that is not a cube. There will be no problems. So again, after a quick calculation, we can check that if in the worst case we should still have about 12,000 vertices spare, just to be sure there will be nothing messed up. So how can we make it? Let's make a new script called chunk. public chunk mono behavior. I think today's stream will be a bit longer because I want to finish this. We'll just finish when I will finish this chunks. And it will contain its own map of voxels instead of the voxel map. It will also have the position, so vector3int public vector3int position get private set. This means that we can only get it from outside and set it we can we can only set it from inside the chunk. And we can just do a public void create chunk, public static void create chunk, and give it a position. So vector3 position. Maybe not the void will return itself. Chunk. And it will make a new game object with the name of chunk at the position, and add a component of chunk. So be chunk and chunk dot position equals position return chunk. That's it, our simple chunk script. Obviously want to have a set and get of the chunk, so you can also do that. So it will try get value and set the voxel, and we want a update chunk method yeah, I think that should be it. We just add the chunk to the map, and yeah. The problem is when the player or rather other scripts don't want to guess what chunk is it. They just know the position and then they just want to set the value. We'll make a special method that will in the voxel map it will just find the correct chunk and place a block here. But we also want to guarantee that if we try to set or get a block from this chunk, but the block is on the other chunk, we will get or set the block and will not just make something dumb like place the block in not a correct chunk. Oh, and we need a public const int chunk size. Will be 13. Okay. Okay. So, how can we make it? First, we can make a method public bool is inside chunk, and it will take a vector3int position. It will take a block position. Position of the block, not the chunk. And we can check if the block is inside the. I will try to comment all of it before I upload the version, like comment all of it. So is inside chunk, we'll just calculate the position inside the chunk and then return the bool if it's the correct position. Let's just say that the first block on the chunk 0, 0 will have the position 0, 0, or 0, 0, 0 rather. So that means that the first block on the chunk 0, 0, 1 will have the position 0, 0, 13 because we count from 0. And that's just it. So we just take the position, get the chunk position, so var chunk position, which is position, which is new vector 3 int mathf dot floor to int position dot x by 13. Oh, we don't have to floor because it will floor for us. No, we have to floor because this would give us wrong answers when using negative numbers. So we have to divide it by a float and then floor it. And return chunk position equals position. Big position. That's it. That's the whole thing that we have to check if it's inside chunk. So let's make the method a bit bigger. The get method. Okay. So get and if is inside chunk position, return what we got, except this position is the how can I say that? The absolute position of the world position. And I think we want this to be local position. Or do we? We could just have a one voxel map and render it in different chunks. So we wouldn't have to do this. Is it better? No, this way is better, and you will see why. You will see why in a moment. And we want the this to be local position because it will make the calculations for rendering easier. So we want another method, two methods rather. It will be to local position or to relative position vector int world position and this will just return okay, this will just return new vector 3 position dot I have to check something. I think oh, but I think that works. I think it should work. So position dot world position dot x modulo by the way, there should be chunk size but float. I just realized, sorry for that mistake. I should be able just to do this if my calculations aren't wrong. Okay, and public vector 3int to world position, vector 3int relative position, return new vector 3int. Oh no, it will just return position times chunk size plus relative position, like that, and that should work. So if it's inside position, inside chunk, we return this. Else we just return the map. We'll just make a new new addition for the map in a second, that we can get it from anywhere, and then we'll be able to get the correct chunk and return it. Give me a second, I'll be back in, well, a second. Okay, I'm back, sorry for that. And we can get back to coding. So, you now have to somehow get the map, get the correct chunk, and get the block from it. So, how can we do that? We will fix the set voxels in a minute. First, let's make the map accessible from anywhere. For that, we'll use a concept called singleton behavior, or singleton, just singleton. So we have a static instance of voxel map, which is a property with only a getter. We'll also have a private static instance, and this will be the proper field. So instance instance, it will check if instance is null, create a new game object called name of voxel map, and add the component to it, so voxel map, and then return the instance. And we also need a private awake function. Awake function is just like start function. The difference is start function will be executed one frame after the creation, and the awake is executed when it's created. So after this, but before this. That's the difference. So it's before this, so we can set the instance. So if instance is null, instance is this, else destroy, no, game object dot destroy game object. So this would be the second map. So we don't want it. We just want to get rid of it. That should be it. So this is the singleton. Now in the chunk we can just do vortex map dot instance, and we have the access to the instance of the map. That's it. And this also guarantees that there's only one map, because we don't want more than one map. Now let's fix the rest of it. So we want to have this kind of accessor, not accessor. Yeah, this kind of function, so we can access the blocks. But obviously we don't have the voxels anymore. Instead of that, we want to have a dictionary of vector3int and chunk. So it will have all the chunks private chunks equals new, yeah, and it will just return chunks try get value position. We need a chunk position because this is a block position, so we need a function public vector3 get chunk position vector3 block position, and we return new vector3, which is basically block position dot x divided by 13 by chunk dot chunk size, and we copy it 2 more times with y and z. Okay. Try get value with the chunk position, so get chunk position of position out var chunk, and if there is a chunk, we just return chunk and does the chunk get where is it? This. So we have to do it to relative position. Yeah, position. Yeah, because we passed the world position here. So chunk dot position. If not, we just return voxel type dot empty. Because if there's no chunk of it, we just assume there is a. Yeah, we can make it static, because why not? We can also make it to this, and then set voxel. We'll update it because we'll need it in the chunk. So set voxel. It will check the position. That's good. And then if the current state is the same, return. That's good. And if not, we can just do get chunk public public void try get chunk, because we also will need to get a chunk, public bool and vector3int position and out var chunk out chunk, sorry, and it will do basically the same as so. Return chunks, try get value, position out chunk. So just a wrapper for this function because this is a private. That's it. And we can also transform it to the lambda expression. Okay. So now we can do first we can check if there is a chunk with that name. Oh wait, try get chunk, but we would rather, no, it's okay. So we say see if there is a chunk. So if not try get chunk of get chunk position of position out var chunk, return nothing, and if it is, we can check the chunk because it will be faster. Then we can set the chunk set voxel. I know it's not fixed yet, but we can do that. Position state update. And there is something we have to touch here, but I will just leave it to for fixing in the next stream. So we won't update the map because that's unnecessary. If we want to update, we'll update just the chunk because the only chunk is changed. There is an error in the thinking, but we will change later. We don't need update. Update map is basically update each chunk. So for each chunk in chunk.values, chunk.update chunk. Okay, that's fixed, I think. Now let's fix this. So if the block is not inside this chunk, we can just say voxel instance of position. That's it. And the same for this. So if is inside chunk position, if it's not, we can just redirect it to voxel map instance dot set voxel position state update. And there is another error in this, but we'll fix it in a minute. And now it's not like a big error in the first, but this one would be a big error if it's not, and we'll obviously can return. If it's not, check the position. If it's the same, that will leave that the same. That's okay. Okay, never mind. Okay. And the thing we have to change is the set voxel. Why? Because we might try to set the voxel of a chunk that is not here. So this shouldn't be here. This was just a temporary measure. We should just, if there isn't a chunk, just create a chunk. So chunk dot create chunk of, that is a chunk to get chunk position. that should be it. I will comment it. I will comment it all after the stream for you. And now let's check if it's working. I hope it's working. So there's no. Start 77. Voxel map 40. Okay. Va current state. Okay, right. So chunk equals this because we didn't set the chunk. Now it will work. Oh my god. There are a lot of chunks that have the same position. That shouldn't be happening. And do we see the blocks? No, we don't see the blocks. I forgot to add the chunk to the chunks. So chunks.add chunk.position chunk. Yeah, now that should be fixed. No, there is no mesh filter because I forgot to add all the things. So just need to add chunk.gameObject add component mesh filter, chunk.gameObject add component mesh renderer, and chunk.gameObject add component mesh collider. Now I hope there's a lot of code without checking, but we couldn't check. Yay, it's working. Obviously everything is pink because it doesn't have any material, but after adding material it seems that it works. And as you can see from the top-down view, there is all the face rendered. That's really good. And can we place things? Let's check. Oh ho ho, Stack Overflow. That's really bad. So the Stack Overflow means that we made some of our calculations wrong, because it will get the chunk if it's the wrong chunk, and the chunk will think that it's wrong, so it will redirect again to the voxel map, and the voxel map will point at the same chunk. It will just hop back and forth indefinitely. So let's see where we made an error. So set voxel uses get chunk position. Get chunk position is 100% right, I think. It should be right because this is int. Oh, I know why. Because it has to be the same thing again. Float and then float. The problem is that -1 divided by 3 is 0 and not -1. And it should be -1 in this example. So floor to int. And that should fix the issue. I wonder why it didn't crash when it instantiated all this, or set all the blocks from the loop. Funny. Let's see now. Maybe I just... Oh, we can place it. Nice. Can we remove it? And we can remove 2 chunks. Nice. I'll add a material, obviously. So probably when I create a block here, it will create another chunk. That's good. But if we take a look inside it, you can see this face is still rendered. And this face is still rendered too. Why is that? Because when we add things to this chunk, it only updates this chunk. So when we add it to this chunk, it didn't update this chunk. I don't know why it doesn't check. Oh, I know why it doesn't check. And always on it only checks the blocks in given chunk. And we will be able to fix that in the next stream. So today we added the textures, we added placement, we added chunks. There's a lot of things we added. That's really good. We are doing it really fast. If someone if it's too fast for someone, message me, or that would be better for me. You can just look at the code. It will be uploaded to GitHub. The link should be in the description. If there is a description on Twitch, I don't know. I'm just streaming. So that should be it. Thanks for sticking with me. If anyone sticked with me, I have no idea. Then yeah. Oh, by the way, I'm dumb and I didn't record the previous stream, but I recorded this one. You will be able to check it out on YouTube. That's it. Thank you very much. Bye.